We are going to wait just another minute while everyone starts joining. So hold on and we'll be with you soon. Welcome to the Latency Kills webinar. I am excited to be with you this morning, bringing some expert speakers on this topic. My name is Tonya Witherspoon. I'm the Associate Vice President of Workforce Development and Industry Engagement at Wichita State University. Wichita State University is an anchor institution driving the state of Kansas's economic engine. We bring together resources, ideas, expertise, and student talent alongside over 50 companies that are located on our innovation campus to create a powerful ecosystem for innovation. Wichita State is proud to add DE-CIX and Connected Nation's IXP division to our partner ecosystem. We are working together to launch Kansas's first ever internet exchange point. You heard that right. First ever in the state of Kansas. The IXP facility will enable networks to interconnect directly on a high performance internet exchange platform, addressing one of the most pressing infrastructure challenges of the modern age, the need for low latency, AI ready, neutral infrastructure across the corners of every part of our country, especially in the traditionally underserved heartland, which is where I'm speaking right from the center of the United States in Kansas. As a public university, Wichita State sees building this infrastructure as a national imperative, very similar to ARPANET, the government funded collaboration with universities that laid the very first foundations of our modern digital world. We are going to be breaking ground on this internet exchange point this week on Thursday at Wichita State University. So look for some more news on that as we build out this infrastructure. So with that, I would really like to have our two speakers introduce themselves. I'll let Ivo go first and then Hunter, and then I have a few direct questions to ask. And of course, we invite the audience to put questions in the chat, and we will ask those as they come in. So Ivo, please introduce yourself.
Thank you, Tony, for this great introduction already. My name is Ivo Ivanov. I'm CEO of DE-CIX. DE-CIX has been operating internet exchanges for 30 years now, so we're talking about a lot of experience in the operations of interconnection platforms or internet exchanges. As of today, DE-CIX operates internet exchanges in 61 different markets on 5 continents. 7 different markets are already up and running in the US. We entered the market of New York 11 years back and have built, as of today, the largest ecosystem already in this part of the country and the 3rd largest on the entire continent. The total number of networks connected to the different platforms of DE-CIX around the globe sums up to 4,200 something. They change every single day. and the total connected capacity is around 200 terabit, and the live capacity, which is even more important, the tons of traffic, is about 30 terabit per second. Connected networks around the globe are all of the different types of business models you can imagine, giant networks like hyperscalers, OTTs, mid-sized networks, ISPs, fiber guys, um, carriers, content delivery networks. We are most probably talking about all the different business models represented on our internet as of today. Who is the internet is part of, who of the internet is part of our ecosystem, and nowadays we even see also enterprise organizations, verticals. They started more and more being attracted, and literally as we speak, live on our platforms globally, of course, including the United States operations. I would say good morning, America, again, with this great statement, latency kills. In the past, I call it latency is the new currency, but I believe latency kills is even more progressive.
Thank you very much, Ivo. Hunter, can you please introduce yourself?
Sure. Thanks, Tonya. My name is Hunter Newby. I'm the owner of Newby Ventures. It's my own holding company. I make directed investments into the network infrastructure space and also related areas. But I've been in the network neutral interconnection business since the late 90s. One of the founders of a company called Telex at 60 Hudson Street in New York City, where I got started solving local interconnection problems between disparate networks. And I continue to do the same thing today. So I've been a partner in a lot of different ventures. A couple of them were nationwide, building a standard for neutral meet me room type interconnection, which today we're referring to these structures as internet exchange points. I want to be very clear that I'm in the business of building, acquiring, or in this case in Wichita, building buildings to a very specific specification to accommodate network operators, basically fiber networks um, that enter the facility in an organized fashion for the purposes of being interconnected to each other. And there's a function, a service that happens within that physical building, in that operating business in the room, known as the Internet Exchange, or IX, and that's what Ivo and DE-CIX does. I've known Ivo 20 years through many different relationships in terms of business. I was actually the master of ceremonies of an annual customer event that DE-CIX was one of the hosts of in Frankfurt for many years. And also when, as Ivo mentioned, when DE-CIX came to New York City 11 years ago, um, I was honored to host them in a building that I was a partner in at the time, to bring them into New York City. And they also entered a couple of other facilities that were formerly mine that I had exited. So Ivo and I have been doing this together for a long time. And now it's our pleasure and our joy to be working together with you, Tonya, at Wichita State University in Wichita, to bring the internet and internet exchange points and the reduction of latency to places where it isn't today, all across the United States, starting in Wichita. And it's very appropriate and timely relative to AI and the sort of genesis of AI and the notion of AI in the training model sense that it didn't care about latency and it didn't really matter where it went and it just chased power. And that may be true for that flavor of AI, but there are other flavors of AI, such as inference and certain you know, deployments of inference, and agentic AI, which is self-training AI, that is very latency sensitive. So the timing of us all coming together, us, to do this and to teach others what we're doing and how this works and how this impacts what they're all trying to accomplish, it couldn't be better. So I'm thrilled to be here. Thank you.
I completely agree. And I think it is also very, very brilliant to have the strategy to maintain the carrier neutral piece of this infrastructure by placing this facility that you're building on a public, university's land, the state of Kansas's land. So I'm very excited about that. And of course, the state of Kansas is also very excited because they have provided an infrastructure grant to assist with that building. This is important for the economy in Kansas, which is going to drive a lot of new opportunities for the manufacturing, precision ag, precision oil, and gas industries that we already have that are critically in need of low latency. So let's kick that off with a question. So latency is often cited as the critical factor in network performance. Can you explain why latency is so important and why it has become such a buzzword recently? So back to you, Ivo. You want to take that first, and then we'll let Hunter chime in.
I absolutely can. I'm very happy to do it. I'm a big latency lover. Why? First, because exchanges, internet exchanges like DE-CIX, they heavily support the optimization on latency and reduce the latency to a possible minimum given physics, of course. As we know, latency stays for the speed of light. There are certain borders related to the speed of light given by the nature of the light. However, building smartly and in the right topology way infrastructure, digital infrastructure, we can challenge these borders. So an internet exchange stays for the lowest latency possible because at internet exchanges, networks, they do connect directly to each other. So a content delivery network or a content network, like let's take the examples of a couple of those, given Apple, Netflix, Amazon for their content, for their entertainment and all the productions they have, Disney Plus, just to mention a couple of more here for neutrality reasons. If they send their packets requested by the users that are connected to an internet access network, they will be happy to do it in the most direct and the most shortest path possible to reduce the so-called latency. So the packet that has been required by the user of a movie or entertainment broadcasting show arrives as fast as possible. Just let me put this into perspective. What does it mean in terms of latency requirements of our new era of life, of instant, of enjoying the best performance possible. A standard video on demand, but not in high def, not in a great resolution, it's just video on demand, requires already kind of a 45 milliseconds. But if we talk about high def, if we talk about the content quality users want to enjoy, then we're talking about lower than 30 milliseconds. Now, if it comes to live broadcasting in high def, in 4K, in ultra high def, we're talking about latency that is even lower than 15 milliseconds. We talk about online gaming in almost real time, in communities where the kids are just live playing. I think this is a great example for a latency that should be also lower than 20 milliseconds. If we talk about business applications that are critical to organizations in lifetime, being delivered real time, being delivered from the cloud, we're talking even about a latency lower than 15 or 10 milliseconds. And if we talk about robotics and a real-time automation on mobility, like the cars as an example here, we're talking about latency that is even lower than 5 milliseconds. So this gives us a perspective how important latency is. And now probably the audience or the participants in this webinar, some of you guys are asking yourself, okay, milliseconds, but how is this related to digital infrastructure? Just very simple. 1 millisecond reports for 50 miles, 50 miles. So talking about 5 milliseconds, we're talking about a maximum of 200 to 250 miles of radius from the devices to the traffic and the compute needed. We'll touch later on this, but I think this gives a perspective how important latency is. And now I'll give you a very prominent example before I hand over to Hunter, who has certainly a lot to say about this as well. Um, just a couple of months back, a lot of friends of Mike Tyson, they wanted to enjoy a live show on Netflix. They had to experience a big outage in live TV of 65, not milliseconds, seconds is very relevant. And this happened because you could not cache live entertainment. It has to be delivered on IP as close as possible from the source to the access internet network. And this is now a good example of the great requirement for the lowest latency possible.
Ivo, thank you for that. And I think that really sets Hunter up to talk about geography. Geography matters, and what is your plan? What are you doing to really bridge the east and the west coasts of the United States, which leaves a lot of us in the middle, Kansas being smack dab in there. So
Yeah.
tell us more about latency and geography.
So yeah, it really, as Ivo said, it's all about physics. And the real estate adage, location, location, location. The major markets have been established for many years because of critical mass of business and people, and critical mass begets critical mass. But the best analogy for just, people in general that are just living their lives, not understanding how their phone works or how the internet works, but they use it, right, every day. Latency matters to them and it impacts them when they're trying to do something, and they get the spinning wheel of death, or the links don't work. And there are a lot of reasons at different layers of why that doesn't happen. But latency definitely impacts your life when the application you're trying to use doesn't work. It freezes, or as Ivo just said, watching a video, the experience is poor. So in terms of physics and geography, this is very analogous to airports. Think of traveling. As anyone wants to travel and fly from one place to another, they want to go direct. I don't know a single person that wants to take connection flights through anywhere. Everyone would prefer to have a direct flight. That saves time, and it also reduces, risk. Um, and in some cases, it could be more cost effective. But time is definitely the element, the quality of going from point to point, A to B. And when you think about how the internet was built, it's along the lines of the legacy telephone systems, which is along the lines of the legacy telegraph networks, which is along the lines of the rail throughout the United States and other countries, and where basically train stations were established, if you think about it. And then from there, a whole town was born. It's very similar. So there's a term that, unfortunately, that applies to a lot of cities that are sort of in the middle of the country or anywhere that's unserved, and they're called flyover cities. And the internet actually routes through those cities, but doesn't break out. The fiber actually goes through a lot of these places, but there's no way to necessarily access it. And that's a similar notion to an airport. There's really no place for the planes to land and take off from for people to have access to. And effectively, what we're trying to do, my partners, Connected Nation, and myself, as we've diligenced the whole United States, we've looked at every city that has a population minimum of X and distance to the next closest established internet exchange point of Y, is to try to eliminate these locations, these physical geography points, where the internet simply doesn't live. And a few years ago, actually many years ago, I wrote a series of articles in industry magazines about this, the Meet Me In series. Everybody in the industry pretty much knows that. And that was me profiling the major carrier hotels, which is the building where the fiber networks all reside, and the Meet Me rooms are the room within the building where they all extend to interconnect to each other in the major markets. I revisited all of that a few years ago, um, through an API that I had built into something called PeeringDB, which is a database of all the internet exchanges, internet exchange points, and IP networks that use them in the world. And by looking at the inverse of where they all are, I saw where they're all not. And that's how the map presented itself to me and others, which is all published on my Newby Ventures website. Anyone can go look at it right now. And that's how you can clearly see the states that lack an internet exchange inside the state today. And that is effectively like saying they're lacking an airport for the internet. And if you're lacking that physical infrastructure that's local to your state, and in some cases, there are states that are very large that only have a few internet exchanges, or just a couple of cities that have them. If you're lacking that infrastructure, well, we all sort of got away with it for the past, whatever, couple of decades as applications were built that rode on top of the internet, like video, real time live sports and entertainment. The need to reduce latency became apparent. And now we've crossed over even from that into AI. And we've moved away from the training model. AI is the, sole and exclusive, uh, iteration, let's call it, of AI to inference and agentic. And that means that those cities that have been passed over in the past, again, a certain population density is sort of required. Wichita's a really great example. Major, state land grant university with a student body population as a starting point, okay, an epicenter for a neutral meet point for fiber networks, both local and long haul, to establish a presence, to then bring in, to create a physical environment to bring in an internet exchange such as DE-CIX, to then create that local routing point such that the low latency between users and applications can be facilitated. That's what we're doing. The physics of it, the formula of it, um, is established, and it's very generic. It's very applicable. It's the location that it has to go to be applied, the order in which it is done, and the time that it's going to take to do it. Those are the challenges ahead of us, and of course the capitalization of it, which is something that I work on daily. But by creating that map, by looking at the places that weren't being addressed and then addressing them in an orderly fashion, based upon physics, based upon logic and need, the demand is there. It's massive. One of the applications that I'm aware of, um, is for banks, and fraud detection. So I was talking about low latency in terms of gaming and video. Fraud detection from the major banks is something that they want to do at the keystroke on the phone as it's occurring. That is a 3 or sub 3 millisecond requirement. And without drawing big network maps and explaining how that all works from someone's phone to a router to a server to doing the querying, um, that takes the round trip delay distance in optical miles down to something very, very short, about 75 in each direction, to get it to that number. That would require neutral physical infrastructure, land such as WSU, buildings such as my own, an operating colo business or interconnection business within it, and an internet exchange such as DE-CIX inside of that, and all the local networks connecting to it throughout the United States to the tune of thousands of facilities like that. They don't exist. And though this is not edge data center, this is not edge computing, this is interconnection. It literally starts at the lowest layer first: dirt, buildings, fiber, and then the internet exchange layer two, basically, in the OSI model. That all needs to be created in order to create the environment for the banks to be able to do fraud detection at that speed. And that's the way that they want to do it, to capture it so that they can stop it. So fraud detection becomes fraud protection, so that they can detect it, check to make sure that it's actually fraud, and stop it before it ever occurs. And the banks are saving billions. So the ROI is built in for them to buy the newest, latest, and greatest GPUs, but they need a physical place to deploy them. And all of that other infrastructure that they rely on in the big cities that already exists doesn't in all these other cities. So that's really the gap that we're trying to fill, and every other application that comes on top of it.
You two have made some very, very, very good points. And I really like your analogy, Hunter, of airports, international airports, hops. How many interconnection flights do you have to take? In mid-level cities, we often have to take two connecting flights to get somewhere, adding hours and hours of time. So we live with that. We don't love it, but we fly, a few times a month. When you talk about the examples that Ivo, you and Hunter both shared, wanting to watch live events, the Mike Tyson fight, or wanting to be safe from financial, you know, intrusion, and security. Those are not just frequent. Those are every second of the day, every day of the week, 24 hours a day. The amount of frequency that we need to be able to get on a plane and have a direct flight is changing for everyone. And I think one thing to remember is not just for all of the middle of the country that doesn't have this, but it's also the redundancy and resilience that the entire country and globe need so that we're not dependent on the few nodes that have already been built. So I love this. Let's take a deeper dive. You started it a little bit talking about round trip delay and how that really affects latency and why it's very, very important that these internet exchange points be built to enhance this. So Ivo, you want to start? Back to you.
I can start. I love the example of fraud detection. I think staying with examples is very useful for the audience to understand the huge need for the lowest latency possible, as already explained, very related to the number of miles. That's so simple physics. Hunter mentioned fraud detection. I will give another example. Cars. Let's talk about autonomous driving. Should the cars stop the borders of a Bay Area because they do not have the infrastructure to drive further autonomously? Is it true that the people in the middle of the country, they do not deserve to drive or use autonomous cars? Of course it's not true. Everybody should be able to use this everywhere. Nationwide usage of autonomous driving. How this would be possible without the infrastructure nationwide in every single region, in every single city, not the big cities on the east and west coast only. And I will illustrate this giving an example how the traffic flows around the car, they function. 70% of the data related to the connected and autonomous driving car, but even not autonomous driving, the connected car only, they can be off and downloaded when the car sleeps. The car is in the garage, right? But the other 30%, they're very interesting 30%, because 20 of those 30 are car to cloud. Another 5 are car to car in real time. And the remaining 5 are car to environment, to sensors on the street, to traffic lights. Now everybody understands this is real-time communication, and the same is valid for what Hunter mentioned about fraud detection. If this doesn't happen like that, the car will crash. It will be an accident, big damage, reputation. People might be killed. This is horrible, right? Now we understand how important this localization of infrastructure that will allow that cloud resources will be as close as possible to where the cars are. That the car communication using also local mobile infrastructure between a local data center and the car itself to be able to talk to another car has to be as close as possible to where the cars are. In other words, the cars, they will not get into the data centers. The data centers, they must get as close as possible where the cars are. So we are already working on a concept of a very small setup of exchanges that will be used in facilities like Hunter mentioned across the entire country, serving that requirement of latency that reports to a radius of 80 to 150 miles. This is what we're talking about. Facilities like the facilities Hunter and Connected Nation they want to build across the country, but also internet exchange just platforms on the highway crossroads, right? Next to mobile cell phone towers. This is what we're talking about. And another very prominent example is the example of robotics. Already used in manufacturing facilities, and those manufacturing facilities are not in the heart of Manhattan. They are not in LA. They are not on Broadway. They are not in Hollywood. They are the center of the country. Big investments. I'm talking
Kansas.
about agriculture. Sorry?
In Kansas. That's
In
where they
Kansas. In
are.
Kansas. Agriculture today is automated, deserves to be automated. We know there are tomatoes talking to sensors, etc. But all this needs to be supported by digital infrastructure. Talking about robots, Tony and Hunter, you know, I love the topic of AI inference. Hunter touched on this. Now, let we all imagine the example of general AI, generalized states for robots that behave like human beings. And we at DE-CIX did analysis. How is this related to latency, measuring the functionality of our brain on a normal day without hangover and without being sick, and translate this to latency. And there are three elements. They will be used in the Gen AI robotics. The sensor information on tactile information, feel, warm, cold, soft, hard, etc., and action, video, and audio. Tactile requires better than 18 milliseconds, video better than 12, and audio requires better than 1 millisecond. Now you understand why I'm talking about 50 to 100 miles, because 1 millisecond reports to this range. And if we want to have a normal behavior in this new age of robotics, normal, close to human being, the infrastructure needs to meet this lowest latency requirement of 1 millisecond. I hope this illustrates the infrastructure we will need to build to have one beautiful day support in different areas of our day life and our business and private day life, as many as possible. And therefore, I'm very proud that DE-CIX announced a year back the concept of AI as a service inference exchange, AI exchange, that will be enabled from day one in Wichita.
Excellent. Hunter, talk about RTD.
Well, round trip delay is, well, it's an acronym, RTD, and in this industry we have many of them, and it's very important to understand. And I think again, AI is a service, let's call it, but AI is a concept. A lot of the people that are in AI from the GPU perspective were Bitcoin miners just a few years ago, and latency didn't matter to them. A whole lot of things didn't matter to them. The facilities they were in didn't really need a roof. These people would deploy GPUs anywhere to mine. And although I sort of, I don't know, I never dabbled in any of that. I was aware of it. I had some customers that did that. I didn't necessarily, from an infrastructure perspective, pay much attention to it, um, because it wasn't in keeping with what, we in the network interconnection industry believe is required for redundancy, N+1, N+2, that sort of thing for backup. They didn't need that. And similarly, they didn't understand the concept of latency because they just needed basically an internet connection and they could mine. That sort of poured over into AI originally, ChatGPT and everything else, and then it sort of proliferated from there. Um, but that's sort of lingering still, like that latency is now relevant to AI. It's irrelevant. It's just wherever there's lots of power, that's the only thing that matters. And that's not true. That's not the case. And unfortunately, I think a lot of investors made big bets on data centers for AI that required lots of power, hundreds of megawatts, even gigawatt level. And they're learning the hard way by the fact that the grid doesn't have it and utilities are pulling back. And They can't create it with behind the meter strategies, whether it's natural gas or nuclear or anything that's going to be sooner than 4 or 5 or 6 or 7 years from now. And that has a serious detrimental impact on rate of return on capital, if any. And at the same time now, latency is becoming important. And this notion of RTD, and I've been asked on more than one occasion by some friends of mine that are really big fund managers, capital managers. Um, I heard one of the hyperscalers say RTD. It sounded like it was important. What does it mean? And these are people that have billions of dollars deployed in data center. The term is so generic, it means nothing. Um, so now interconnection matters and understanding how interconnection, where that happens. It's not just about power. It's about interconnection. It's about latency. It's about RTD. It's about round trip delay. And again, the airport analogy and the fact that, you're in Wichita and you know what that's like to have to connect and how long that takes. We're focusing on that, right, for the internet, generally speaking, content, cloud gaming, but now AI, where it becomes very important, as Ivo pointed out. And I would just say that um, given that last year the Department of Defense declared AI as a national strategic imperative, right? It's at the level of military. Um, we must deploy AI. We must do it first. We must do it the biggest. We must do it the best. Okay, I agree. But it's not just about power and supply chain and labor and mismatch and all the other myriad potholes that are out there standing in the way of execution. It's also about latency, and that's RTD. So gone are the days where you could say, I've got powered land and fiber is a mile away and fiber is the fastest, so therefore latency is not a problem. None of that makes any sense. And we need to stop allowing people to say that. You need to actually be qualified to have a conversation when it comes to interconnection. Um, and it isn't just about fiber, it's where the fiber goes to, and if it's accessible, and can you access it as dark or lit, and what's the distance to a point, and at that point, is there a public internet exchange that has the AS numbers, autonomous system networks that you need to connect to? Which one or ones of those networks are they that you need to connect to? As Ivo was pointing out, the car has to talk to other cars. The car has to talk to other things in the street. What are those things? They're on IP networks, but what are they represented by, or which AS are they represented by, and where does that AS appear? On what exchange? How do you pass internet protocol traffic to and from it? That's the level of specificity in terms of network architecture, design, build, and interconnection that's required. If you don't understand that, you can't be in this space. You're building something, but it's not connected to anything, and it's not optimized. And that's what RTD is all about: round trip delay to a point, and on that point, that exchange point, that internet exchange, in that exchange point, what other networks are on it that you need to connect to, and then it becomes very prescriptive. Deterministic routing, which is what we're going to get into now for the balance of this year and into next and beyond, is all about the AI, what network it's on, and what other networks it needs to connect to. Okay, the information it has to collect in order to process it to make a decision. That all has to happen very fast. Um, yeah, so that's what RTD is and how it relates to physics and design and placement of structures that have to be neutral. They have to be open access. Yes, there are rules and there are rates and whatnot to be there. That's not new. Okay, we've been doing that in the major cities for 25 years plus now. It's just taking that know-how and applying it to cities like Wichita, as many as are needed and necessary that are um, respective of the local, right? Number of devices, number of people. As Ivo said, is the car supposed to stop working at the border of the network access? The other analogy too, and it's again a common analogy. This is what anybody can understand: is when you have your mobile phone and you're in a city and you have 5G, or you think you do, but you have 5G. It says 5 and G, and you're on your phone and it's working. And then all of a sudden you sort of move, you go somewhere in that city or just outside, and it goes to LTE, and then it could even go to 3G or worse. Um, that's the further you move away from the core of where investment justified investment in that level of infrastructure directly relates to speed and throughput. And the further away you get from it, the farther down you go in speed and throughput. And if the DoD wants AI to be a military imperative, it must be ubiquitous, and we must have a plan. And that plan cannot just be to chase power. Putting the hyperscalers on national laboratory land because they've already got nuclear reactors, and bringing in the Department of Energy as cover for new reactors to be deployed without oversight from FERC and NRC and the PUC is great if that's what you're trying to achieve. But what does that actually have to do with the reduction of latency? Not much. So both of these things need to be considered in order for the whole to work optimally.
Yeah, you guys have both used a lot of terms and acronyms and networking jargon that our networking engineers certainly understand, but lay people, business people that are trying to think about investment, technology, digital transformation for their companies, trying to understand that. Try to talk in just real business terms, and I really like some of the examples you've given. What you shared is that we definitely need to be thinking differently about our networks. So what considerations should enterprises keep in mind when they're designing network architecture for the future? And one that I know I've learned from both of you is that thinking about your network as what happens in the building that you have is not nearly enough. And it's not nearly enough to even think of, maybe the 2 satellite offices that you've got, in other locations. Because with inference, with all of the data that's moving, all of that, you don't know where you're going to connect. You don't know who you're going to connect to. So talk in a business jargon, less network language, and talk about really design for the future. So Ivo, you want to get started, and then
Yeah, I can. I would love to because I have a clear opinion on talking about business language. I think the word of an asset is very important one, right? I think all the enterprises today, different business models, different sizes even, they are absolutely convinced that they need to have very strong digital infrastructure support, because even if we talk about company that has an entirely offline product, like this bottle of water, right? It's offline, I hope. The processes behind this are already digitalized. And the second thought related to enterprises is about digital assets, creating digital assets, because creating digital assets will secure new revenue streams. We develop new revenue streams. We create success. We'll create another job types, right? And therefore, this is very important for enterprises to make sure that their processes, their critical systems that are digital today already, they function in the best and most secure way possible with the best performance. And second, to create new revenue streams, building digital assets. Now, if we asked ourselves how a digital asset can be built by an automotive company, to staying with the car example, right? It only can be built, and this is valid for all the different other types of enterprises, financial institutions, logistics, retail, etc. It only can be built if the enterprise controls the data journey. If the car manufacturer plays the gateway between the buyers and the suppliers of data into the car, right? If they do not do this, this will be done by Apple, Microsoft, and Google. They would love to do it. But if General Motors, Ford, BMW, whatever, they want to create this asset, they need to control the data journey. Because if you control the data journey, you can build assets, monetize assets, create nice digital plans, or how they speak already about is the digital car experience, Now, controlling the data journey is not possible without having your hands on infrastructure. So digital infrastructure. So all these type of organizations, automotive, finance, etc., they need to build their own networks. They need to get engaged in infrastructure. They need to become present in all those data center facilities Hunter's has been talking about. They will naturally need to become part of the digital infrastructure industry and heavily engaged in being able to secure their success, their growth for their shareholders in the next decades. And if we talk about AI, every single enterprise CEO already talks about, most probably, then we are talking even more about this new edge of new infrastructure, the new internet we're talking about today, the internet of the lowest latency possible. Because if they want to use the millions of agents that will be available very soon and partially are available, they need for their inference processing not be present in a gigawatt data center. They will be need to be present where the agents are as close as possible to. And we will see in the future a lot of examples, as DE-CIX already started to experience this, where enterprises will heavily get engaged in this type of infrastructure we are talking about, creating the best performance on their networks as possible for their customers and for their business growth.
Ivo, those are some great words, and I want Hunter to chime in on this. But before we do, we have just a few more minutes after Hunter talks to maybe take some questions. But I also want you to be thinking about this. Ivo's put a good point of partnering with this infrastructure. Enterprise needs to partner. If you were going to think about how to design your network architecture for the future, one of the first things would be to partner with the new infrastructure that's being laid and to envision and innovate what you could be giving to your customers because of this new infrastructure. So I want everyone that's participating to think on that and put your questions in the chat if you have them, while Hunter gives us a little more, information about planning for the future from your perspective.
So thank you, Tonya. Yeah, this Ivo just said it. It's the new internet. This period that we're in right now, for me, um, it brings back memories of the beginning. I came into telecom when it was still, and not to use more acronyms, I know, but it was still telecom. It was still what we call TDM, time division multiplexing. Copper T1s, E1s. People don't even talk about that stuff anymore. And that's how I came up in this industry. I learned all of that, and then I figured out how to eliminate the latency or the lag time in getting networks connected to each other by eliminating the local circuits, local loops, and building a room in a building where all the networks that wanted to connect could meet. And then I organized that. That was innovative 25 years ago. In the big cities, that's known, but in places like Wichita, they've never heard of it. So that's interesting, that disparity. And I could say the same about AI and the biggest companies in the world trying to figure out how to use it. It's all new, right? So take yourself back in your mind to when the internet and the web and websites and email was new. No one had it. So, trying to explain to people why they needed to use it when no one else had it, it's like, why should I use that? Nobody else has it. And then within a few years, from the late 90s to early 2000s, you went from nobody had a website to everybody had a website. And if you didn't have a website, you weren't a real company. People couldn't look you up on the web. You weren't real. If you didn't have an email address, it was like you lived in the village of the, disconnected, where Ivo's water bottle is, hopefully. Um, so um, we fast forward to AI, and the thing that I would say about what we're doing, which is things that we've each done in our own disciplines and lanes respectively, and now we're all coming together to do it, is to learn. And I'll point on a couple of things that I'm aware of that I think would be really great resources. So first of all, most people just want to hit the easy button. everybody can't build their own internet to use the internet, just the same as, UPS and FedEx couldn't build all the highways just because they want to deliver packages. Infrastructure gets built first, and then business comes on top of that, right? So the sunk cost of all this infrastructure, and again, referencing whatever the initial DoD military application is, whether it was the Interstate Highway System or DARPA, as you mentioned, Tanya. AI is similar in that regard, and then business applications, commercial business will be built on top of it. So the big enterprises should build their own networks. I've always advocated for that. The largest should have their own ASs. They should appear on exchanges. They should appear. And Ivo and DE-CIX and other exchanges in the world have had success with that. I would say DE-CIX probably has more success with that than anyone else. Large companies have their own AS numbers and peer just like a Google would, or a Microsoft or an Apple would. That's really great. But there's a level. There's a level where certain enterprises are not going to be big enough to do it themselves, and they're going to need to do what? They're going to need to outsource that or work with someone that can guide them. And consultants of all flavors could be really good guides, and they could also be very good integrators. And there happens to be one on the WSU campus, and that's Deloitte and their Smart Factory. And I think that the Deloitte Smart Factory on the campus of Wichita State University, and working with the people at Deloitte, as one example, for certain enterprises that need to be guided through what is an AS number, how does this work, and how do I use AI. There's lots of layers of people that want to help explain that to them and guide them through. At the end of the day, there's only a few certain little, real estate points of interconnection that are neutral where all the networks meet. Only a few major internet exchanges like DE-CIX, the largest in the world by deployed nodes in countries, that eventually you're going to flow up to. Whether you're there directly or you're buying from a network that's physically there, you're going to go through one of those facilities in order to optimize all of this stuff. And it sounds like jargon. And a lot of the applications and the acronyms are to people that just want things to work. At the end of the day, people just want it to work. They're running something else, some other business. And network and AI is a part of what they're doing, but they don't know how to build it and run it. They just need to use it. They just want it to work. And it's almost undeniable, I think, at this point that AI is going to touch literally almost everything in business. Predictive analysis, and I mean, people are using it to write things and decide things, and insurance and healthcare and actuaries. Everyone's using all this stuff. It's behind the scenes. It's invisible. It's going to impact our lives. Hopefully, make it better. And how that all works, the plumbing of it, is for folks like myself and Ivo and others, to help figure out how to optimize it and make it more efficient so that it works for everyone, so that basically they could just all continue to take it for granted. Most people don't know how the internet works, but they use it every day. AI is just another layer on top of that, and it'll be very similar. So from an investment perspective, I try to make myself available. I know Ivo does too. The man travels the world and speaks at conferences. Should get an Olympic gold medal for it, as far as I'm concerned. And that our accessibility and our willingness to talk about it, and yours too, Tanya, and to host this, is a start. And then there'll be others, as I said, whether it's Deloitte or others that can come along, and take this information and then become more, you know, accessible to the enterprise clients that they work with and serve, to help them understand it so that they can come up with strategies that are efficient, and optimize for them their investments so that they get the greatest return on whatever it is that they're trying to do. But there's no question that it routes back to physical interconnection facilities, whether they're mine or someone else's, and internet exchanges, whether it's DE-CIX or another. We've been doing this for a long time, and we happen to, I think, be pretty good at it. And it's great to be able to help and work with you and WSU and all the wonderful companies, the 50 you mentioned that you have there, aviation, aerospace, engineering, epicenter for the United States, is in desperate need of a serious upgrade in terms of its network connectivity. And we're really happy to do that.
I really appreciate both of you giving that layer of business need and information. And I don't want anyone to feel overwhelmed with the complexity of the networking information here, because just as Hunter painted, this is very similar to when the internet started. This isn't new ideas. It's coming up again because our use of the internet and the networks is different and requires some different thinking and some more investment. It's time to build it out, bigger. So I think the thing I would have everybody, think about is just that your network is probably not future proof. That's for sure. Things are changing. Things are changing in the data fabric, and in the way we're using data, the way we're passing data. So we just have just a couple more minutes, but we had a question that I think is really interesting. So I'm gonna throw it out, and then one of you can touch on it just a little bit at this end. So people are excited. They're looking at the distances we need to, overcome. But how small of an IX can you have? Like, do we need to have thousands of them? Do they need to be little, big? How many feet do they have? How many yards? And what about like from, Europe to Miami? I mean, how do we pass and get through those types of links? So just a
Those are
little
two
bit
very
about
different things.
that. I know. I've given you 2 minutes to answer an hour-long
Go ahead.
question, but give a
Ivo,
little.
it's your world, man.
I'll make it simple. We're thinking about the pizza box size. This is
Okay.
the next generation of an internet exchange. As I said, the highway crossroad or shopping mall or business tower, whatever, as close as possible where the users are. And talking about from Miami to Europe or to Japan, from Seattle or LA, uh, I prefer to say as local as possible and as globally integrated as needed. We'll need both. We'll need a global integration, especially for globally operating organizations. There will be a lot of usage on subsea cables. There will be a lot of usage on long haul fiber or carrier services. They will not be replaced, right? Not what we're talking about. This is the kind of global integration as DE-CIX itself runs a global network interconnecting all the 61 markets. At the same time, we will need this very regional, tiny setups. And yeah, if the question is, do we need thousands in one beautiful day? Yes. Yes, the answer is definitely yes. Do we need another transmission technology like the one I love also to refer to in this from space, so to say, to serve certain regions? Yes, as well. And my last word is watch out, the DE-CIX Space Exchange. You can visit the website of space-ix.net. In a couple of years, I would love to have internet exchange in space, interconnecting there as well. So there are no limits.
Well, my quick
I imagined that you would say that. So we have run out of time. This has
yeah,
been some really,
I was just
really
gonna say,
great
Tanya, one
information.
thing.
Oh,
I know we
say
need
one
I know we
more,
need one
Stacy.
new one in Wichita.
Oh,
I
we do.
don't know how many
And
more
we're
we need, but
breaking
we need
ground. Yeah, we're breaking ground this week. So exciting. Yeah, and we'll be a pilot for other universities and other states because there are 14 states with no internet exchange points. So we're not alone, but it's imperative that we build this infrastructure out
right. There.
together and that we get to the point where there are pizza boxes everywhere. I agree with you. I agree, Ivo. So I just want to point out that there was a explainer glossary that was shared in the chat. So click on that link if you want to dive more. There will also be a recording of this webinar sent out to all participants, and it will be able to be shared broadly. So if you have colleagues or associates that did not attend, you'll be able to share this information. And we thank you very much for spending the last hour with us talking about how latency kills. Have a good rest of your day. I appreciate you.
Thank you. Thanks,
Thank you.
Tanya. Thanks, Ivo.
Thank you.
Thank you.